Hi, everyone. Ready to talk about schemas? Exciting, right? Thank you. This is the best part of the talk, by the way. So my name is Adam Klein. I'm the proud father of two forked versions of myself. It's a complete refactor without all the legacy code. Still in beta, so definitely not for production, but we're working on it. I'm also the co-founder and CTO of Cover. We are an engagement platform. We help companies connect with their employees and customers through e-commerce experiences around their brand. And we're an early stage startup, so it's probably the best time to join us before we skyrocket into a better future. So like everybody else, we're hiring product managers, product designers, and of course, like everybody, a full stack developer. So what's a schema? I have audio, but I don't know if it will. No, audio is not playing. So the word schema comes from the Greek word schema, which means shape, or more generally, plan. Plan. That's why we hate it so much, because we don't like planning as developers. Right? It's the same reason why we're not naturally inclined to write TDD. We have to force ourselves into it, because we don't want to think about all of the edge cases of our code before we actually wrote it. We want to take the requirements one by one and just code it. The same with schemas. If we start our coding by defining the schema of all of the entities and properties, we're doing one of the two hardest things in computer science, which is naming things. The other is cache invalidation, in case you never heard this joke. So, do we hate schemas? No, we just hate writing them. But we love using schemas, because schemas are the language that defines our data structures. It allows us to coordinate between teams, to create a common language. It drastically reduces integrations bugs if we define the schema of our API in advance. It allows us to automate stuff like generate live documentations, validations, etc. And of course, it allows us to write over-engineered generic infrastructure, like generating our entire back-office UI from the schema, or generating mocks for our tests automatically and stuff like that. So let's talk about cars, because we're writing a system for car dealerships. So we have a car in our database, right? A model with, let's say, type, manufacturer relation as a foreign key, and manufacturer date. And we have to define the schema for the database using SQL. We have to, sometimes we use some kind of ORM, so we have a class that defines the schema for this class. And we have to generate API documentation, so we write schema for Swagger, for example, and we have to define validation, so we keep repeating ourselves over and over again. We also have TypeScript definitions for this car entity, and we consume this API somewhere, so we need the same definitions there. Maybe there we're using a different state management library, and we just keep repeating ourselves over and over again. And what do we hate most as developers? Too many things, according to the answers. We already said naming and planning, repeating ourselves. We like dry code. Don't repeat yourself. But I kept feeling in different projects and different companies that we have to repeat ourselves with these schemas and entities and type definitions all over again. And then when you have to add another field or change a field, you have to change it in like 10 different places. And you feel like this guy that has a schema overload, and you just want to quit your profession and be a tennis player or something. But why? Why do we need to repeat ourselves? Well, because different schemas have different properties. They overlap in a lot of stuff, but each one needs special care. So we will never have one schema to rule them all. But we can identify stuff that repeats itself, we can do mappings, and we can try to save ourselves a lot of trouble and rewriting. And let's see how we can do that. So let's take a few examples of differences. So for example, in our database, maybe we have a manufacture date with a snake case, and in our API, it's camel case. That's one difference. Maybe the data type is different. In the database, it's date time, but in the API, it's just JSON, so it's a string or a number. Maybe in the database, it's a foreign key, but when we pull it from the database, we actually pull the manufacturer object and put it on our car object, and then we have manufacturer object with an ID property. So it's not exactly the same like in the database, but sometimes we just pull the car entity as is, and we don't pull the manufacturer object, and then we do get the manufacturer ID. So how can we define one schema for all of these use cases? And sometimes we just have things that are in the database, but we don't send them over the API, hopefully. And also sometimes we join stuff together, like our DB can be flat if we work with a relational DB. And in the API, we join stuff together. So the car in the database is just the car, but the car in the API also has the accidents array and some kind of aggregations of how many times it was sold, etc. So how can we handle all these schema differences? The first thing is just don't have any differences where you don't have to have. For example, a car is a car. If it's in the database, if it's in the API, in the state management library, it will be much easier for you if a car always looks the same, has the same properties, without mixing it with other stuff. So for example, in the API, we can have the car separate, and the accidents array separate, and some statistics that we aggregated as a separate object. That will give us a lot of peace of mind to know that a car is a car everywhere in the system. Also, we can do mapping of stuff without rewriting the entire schema, and we will see how we do it later. So for example, we can map field names from snake case to camel case, or vice versa. We can map, for example, the manufacturer ID to an object that has an ID on it, to make sure that it always looks the same, whether we lazy load the manufacturer object or we just pull the foreign key. And this is, for example, something that TypeORM allows us to do. And we can also map data types, and we can create one schema that is based on another schema by omitting certain fields or picking certain fields or doing intersections between schemas, just to try to avoid repeating ourselves over and over again. And we will see some code examples in a minute. So to do all of this, we need the right tools for the job. And now a disclaimer, I'm going to show just one way to do it, one set of tools. It's definitely not the only set of tools that allows you to accomplish this. It really depends on your tech stack, on your database, on which API you chose to implement. But I hope that any one of you can take, that's how much time was passed, right? Not left. No, doesn't make sense. Okay, I only spoke for 5 minutes. So let's rush it. Ready to see some code? Yeah. So the base for all of this is the JSON schema, because it gives us structure, it gives us type definitions, it gives us validations, and it's extensible. So whatever is not supported with JSON schemas, we can add, like validations for a library called AJV, or open API definitions for Swagger, and we can automatically generate TypeScript from our JSON schema. So if you haven't seen what a JSON schema looks like, this is what it looks like. We have a simple object with 3 properties, and we have an object that defines the structure of this object. So it says it's a type object. JSON schema, by the way, I didn't mention, it's a standard protocol for defining JSON objects. So it has a property, for example, ID with the type, and it can also have validations and other stuff on the JSON schema. But this is very verbose. if you look at the left object, it's very concise, and the right one is pretty big. No one wants to write JSON schemas. So we're using Typebox, which is a concise API, a functional API to create JSON schemas. As you can see, it almost looks like TypeScript, and it has everything that JSON schemas have. And you can automatically generate type definitions from the JSON schema. So this will actually take the schema and create this type automatically, so we don't have to repeat ourselves. And we can also do cool stuff like take one schema and just take some of the properties and create a new schema, or omit some of the properties. So again, we don't have to repeat ourselves. And we use Fastify, which allows us to take the schema definitions, place them on the route, and this will automatically generate the Swagger documentation, the validations for the route, and fast serialization using a library called FastJSON-Stringify, which is based on the same JSON schema. So it's faster, it gives us the validation and the live documentation. And we use the type definition to help us with code completion and type checks, etc., during build time. And for me, the coolest part is that we use the same type definitions in our API utils, in our frontend or in other clients that consume our API. And this is like magic. It drastically reduces the integration bugs, especially if you have like a front-end team and a back-end team, and they can agree on a schema in advance. We generate the type definitions, and then we know that you talk the same language. So to summarize, we have the schema, we generate types, validations, live doc serialization, and the types we use in our servers and in the consumers. What about the database? I don't know how much time I have left for this. So the database also has a lot of times duplications. For example, we have a class. Let's say we use some kind of ORM, and we also need to generate the migration for this object. And there may also be differences between this class and the SQL. So data types differences, field name differences, if it's snake case or camel case, etc. So we use type ORM. It allows us to map these differences inside our class. For example, the name of the table, the name of the field. It will automatically take the type of TypeScript to generate the data type of the database, but we can also override that if we have some kind of different data type. And we can run one command in the command line to automatically generate the migration for us. So type ORM will compare whatever is in the class and the database, and will generate a migration to create new tables, add new columns, etc. It doesn't work 100% bulletproof, but it saves a lot of work. 2 minutes? Thanks. So can we create some kind of mapping between the ORM class, the database, and the types? So why do we need this? Because let's say our API route needs to return the type that we generated from the JSON schema. But we pull something from the database, it has the class of the ORM. We need to have some kind of mapping that says it's the same object, or it's the same object without a few properties. So what we do is that our ORM class implements the type that we generated, which doesn't save us the trouble of redefining the properties, but it protects us from typos, and it protects us for having the same type definitions. And that's it.